your previous studies, you learnt about the quadratic formula, okay? You learnt about the quadratic formula, that whenever you're solving a quadratic equation and you don't necessarily want to factorize the equation, or if you cannot factorize the equation, you use the formula. The formula is usually the last resort. If you don't like completing the square, the formula is usually the last resort that you resort to whenever you're solving a quadratic equation. And everyone knows the formula, right? X is equal to negative b plus or minus the square root of b squared minus 4ac, this whole thing over 2a. When you look at the discriminant here, in the previous videos, we talked about how whenever you're sketching a quadratic function, whenever you're sketching a parabola, and you notice that that discriminant is less than 0, then that graph is actually not going to cut the x-axis. Now, okay, so this expression on its own right here is a graph, it's a parabola, and we learned how to sketch it. Now, having a deeper understanding of how graphs work is that this expression here actually represents the y-coordinates on that graph. For example, if I have my parabola and it's coming like this, if I take every single point along this graph, the y-coordinate of the point on that graph is the one being represented by this expression depending on what x is. So if I have my x-axis here and my y-axis there, let's say I take a value of x right here. If I take a value of x right here, I plug it into this expression, and the answer that I get is going to be this y-coordinate right here. It's going to be this y-coordinate that's right here. Let's say I take this x-coordinate here, this x-coordinate here. I take that x-coordinate, I plug it into this expression here, and the answer that I get from this expression is going to be the y-coordinate there. It's going to be the y-coordinate there. So this expression here, ax squared plus bx plus c, it's actually representing the y values on the graph for each point x that you take along the x-axis. So ax squared plus bx plus c, what this is really saying is, remember that when you're solving this quadratic equation here, you're solving for values of x. So in this process, we were going the other way around. We were taking values of x, we were plugging them in here, and we were getting certain values of y, which were these two. But whenever you're solving a quadratic equation, you're actually working backwards. You're going the other way around because you're solving for x. So you're solving for x. You're solving for x. And the x values that you get here, these are going to be x values such that if you put them in here, the y-coordinate is going to result to 0. So you're looking for these x values here, these two x values here. Because if you take this x value here, it's going to make your graph have the y-coordinate of 0. At the same time, if you take this x-coordinate here, it's going to make your graph have a y-coordinate of 0. If you take this x-coordinate here, it's going to lead your y-coordinate to be 0. You take this x-coordinate here, it's going to lead your y-coordinate to be 0 again. So when you're actually solving this quadratic equation, you're actually solving for the values of x that are going to make your graph cut the x-axis, because whenever your graph cuts the x-axis, the y-coordinate is actually going to be 0. So when you're solving this quadratic equation, you're actually getting these 2 points here, these 2 points, such that your graph is cutting the x-axis, because wherever the graph cuts the x-axis, that's where the y-coordinate of your graph is 0. Now, in my previous videos, we mentioned that there are some graphs which are not going to cut the x-axis. For example, this graph. This is a parabola that doesn't cut the x-axis. What does this mean? This means that there is no point on the graph at which your y-coordinate is going to be greater than 0. This is your lowest y-coordinate. Let's say that's 4, for example. What that means is the lowest y-coordinate that your graph can have is 4. So there's never going to be a situation where the y-coordinate of this graph is going to be 0. What does that mean? It means if we take the expression for this parabola and put it here and equate it to 0, we're not going to get any answer. We're not going to have any roots. We're not going to have any solution. So this graph here is not going to have any roots, any solution. to that equation. So when you try and solve that quadratic equation, it's going to be impossible for you to solve. You're not going to get an answer. This is going to be unsolvable. It's going to be unsolvable. Being unsolvable means there isn't a single point on this graph at which the y-coordinate of that graph is going to be 0. Because remember, the solutions to this equation are giving you x-coordinates such that if you plug them in, you're going to produce y as 0. But if this graph is not even cutting the x-axis, there is no point at which the y-coordinate along this graph would be 0. So your equation would have no solution. So this is the first type of quadratic equation, and we say that the equation has no real roots. Now, this formula right here that I have written here is the formula that gives you the roots of your equation, So you might ask and say, well, how is it possible that we can have certain quadratic equations where we're not going to have any solution, but the formula is right here? If we plug in values here, we should get an answer, right? That's what you might be thinking. But the secret lies behind this square root sign here. Now, basic elementary math tells you that you can't find the square root of a negative number. For example, you can't find the square root of -2. You can't find that. It's impossible. At this level, it's impossible. When you do higher level maths, you learn about something known as complex numbers, where the square root of -1 is equal to I, but at this level, you can't solve this. It's impossible. Try and plug this in your calculator. Plug in square root of -2 in your calculator. It's going to give you a mathematical error. Square root of -10. It's going to give you an error. You can't find the square root of a negative number when we're dealing with real numbers. So what happens if our discriminant here, b squared minus 4ac, is going to be negative? If we get a negative answer in here, this entire thing here that I'm moving my pencil around is going to be impossible to solve. It's not going to have any answer. If our discriminant b squared minus 4ac happens to be negative, this entire thing here is not going to have an answer. So if this thing is not going to be defined, if this thing is going to be an error, it's impossible, because you can't do anything. It's impossible. I mean, if you got the answer here as 4, then the square root of 4 would be 2, so your answer would be -b plus or minus 2 over 2a. But if this thing is negative, if b squared minus 4ac is less than 0, if it's negative, you can't find the square root of a negative number. So this entire thing is going to be a mathematical error. It's not going to be defined. It's not going to be possible. So the entire expression, the entire thing would be unsolvable. It would be wrong. It would be unsolvable. We would have wasted our time. So what does that mean? The equation will have no solution. In general, let me just rewrite this here. The solutions to a quadratic equation are given by the formula x is equal to -b plus or minus the square root of b squared minus 4ac over 2a. So if b squared minus 4ac is negative, you're going to have a negative number going underneath the square root. But that's going to be impossible because you can't find the square root of a negative number. When that happens, this -b is being plus or minus to something that's impossible, that doesn't exist. So this entire thing makes no sense, and you will have no answer. And remember, so this equation is going to have no roots. And remember, the roots of an equation, the roots of a quadratic equation, are simply the solutions of that quadratic equation. So this entire thing is not going to have any solutions. And if it has no solutions, remember, the solutions to a quadratic equation are simply saying, where does this graph cut the x-axis? Because where this graph cuts the x-axis is where y is 0. Because this entire thing is the y-coordinate, and we're saying where is the y-coordinate equal to 0? Where it cuts the x-axis. But if it doesn't have any solutions, there are no x values that are going to give us y as 0, so this quadratic function will not touch the x-axis. So basically, the condition is, if you take a quadratic polynomial ax squared plus bx plus c, and you find that the discriminant is less than 0, if the discriminant is negative, this quadratic equation will have no real roots. It will have no answers, it will have no solutions, you can't solve it, and graphically, this will be the situation, or this will be the situation. Okay, that will be the situation, or this will be the situation. It will never touch the x-axis.